This is problem number 4. It says, for the following reaction and its equilibrium constant, determine whether the position of equilibrium lies towards reactants, towards products, or somewhere reasonably close to the middle. I've had a little error here because my double arrow somehow turned into a delta symbol, which when I want to make a delta symbol, half the time I cannot, but this time I did. Here's my arrow. I have my Kc value. It is 4.9 times 10 to the minus 17. And this is a question about the position of equilibrium. Now, I'm going to write out my Kc expression, and then we'll talk about it, or I'll talk about it, and I'm happy to have you talk about it too. So my reaction takes a solid, and actually this is a dissolving reaction because the solid becomes ions, Fe2+. And question, can anybody tell me if they remember, do solids appear in equilibrium constant expressions?
No.
Thank you, Aziz. No, they don't. You are correct. Solids and liquids do not appear in equilibrium constant expressions. Solids and liquids do not appear in Kcs or Kps. And the reason is that solids, there's a couple of things to say. One is solids don't have concentrations or partial pressures. That's the sort of the first level. The second is, if you could imagine a solid having a concentration, it wouldn't change at all. You can have more solid, you can have less solid, but it does not change its concentration. But what you need to know is that it does not appear in equilibrium constant expressions. And so the reactants here, we could put our line and then just write 1 as our denominator, because that's what subs in. Not a 0, just a 1. And so we could simply write this as the concentration of our products raised to exponents, and we don't even need the 1. Now, if Kc is going to equal 4.9 times 10 to the minus 17, then what that means is that at equilibrium, there must be very low concentrations of our products. At equilibrium, there must be very low concentrations of our products. Which means that we could have a whole bunch of iron 2 hydroxide solid around, and only very little of it would dissolve. And so what I would say is that the position of equilibrium does not lie toward products because we get very low concentrations of our products. The position of equilibrium lies towards reactants. And this is generally true for this and other reactions. If Kc is very small, what's called the position of equilibrium lies towards reactants. And what I said is very small is not a very helpful term. So we decided that Kc very small, or what I said was Kc is less than 1 times 10 to the minus 4. When Kc is smaller than this, equilibrium lies towards reactants. And that means that there will be more reactants at equilibrium than products. Let me back up a little bit so I can get that all on screen. Are there any questions about this one?